Today I'm going to show you guys how to graph the cosecant and secant graphs. So let's review a little bit. How do you graph the sine curve? So these are your notes today. How did we do this is an old problem. We did this last week. First of all, what does it mean when you graph the sine curve? Well, what you do, you are going to take, these are angle measures. And what I did was I typed up the angle in degrees and in radians. So we did 0, then we jumped to 90, we did 180 or pi, 3 pi over 2, and 2 pi. You remember this?
Yeah.
So what we did was, just so you have it down, we did the 0, we did pi over 2, we did pi, we did 3 pi over 2, and we did 2 pi, right? And then we said, hey, what's the definition of sine? Sine is y over r, or you could say opposite over hypotenuse. Now, how do you get these values? Well, if you look at your unit circle, here's your unit circle, and it's all on I typed it all here for you. So, where is 0? It's right here. 0 is the ordered pair 1, 0. Pi over 2 is right here. And what's the ordered pair for pi over 2? 0, 1. And for pi, we have -1, 0. And for 3 pi over 2, we have 0, -1. So at these four places, at 0, the y value over remember, an r is 1. 0 over 1 is 0. Pi over 2, so the y value is 1, 1 over 1 is 1. Then we did pi. Y is 0, 0, -1, and 0. So what did this thing look like when we graphed it? It was on, above, on, below, on, right? Do you remember this? And we did all the way up to -2 pi. So right here is what you have, and all I'm showing you here is the graph of the sine curve. It's a broken, here's your 0 right here, okay? And here's the graph. Now, what I want you to understand is what cosecant is. Cosecant is 1 over sine. So if we were to take these same ordered pairs, and since the definition of cosecant is 1 over sine, all you have to do, instead of saying sine is y over r, it is now r over y. Or hypotenuse over opposite. So basically what you're doing is flipping these ordered pairs. So if you were to flip 0 over 1, what do you get here? What's 1 over 0?
No solution.
Undefined, yes, no solution. And if you looked at this point, actually let's just do the basics. Let's do the basics. Let's do 0, let's do 90. If you flip this, what would you get? What's 1 over 1 if you flipped it? How about the pi? If you flipped 0 over 1 and made it 1 over 0, what would you get? Huh? Undefined. If you flip this one, you get 1 over -1, which is -1. How about this one? Undefined. How about the stuff in between? The 30, 45, and 60. Well, for the sine curve, if you did 30, now where's this 1 to 2 coming from? Well, here's your 30 degree, it's 1 over 2. Opposite over hypotenuse is 1 to 2. So what's it going to be for cosecant? It's going to be hypotenuse over opposite. So in other words, 2 over 1 or 2. What's the 45 going to be? So instead of root 2 over 2, it's gonna be 2 over root 2, and if I convert it to a decimal, it's about 1.4. And this one's gonna be about 1.15. So these are the values. Now, let's look at our graph here. So over here, this was our our y-axis. So our on, above, on, below, on, above, on, below. This is the sine curve. So now, where it was on is now gonna be what? Where it was on, what's happening here? Because this is the cosecant curve right here. What happened is this is now gonna be an asymptote. At every on place, you are going to have an undefined. See how it's undefined here? It's undefined at 180 or pi. It's undefined at 2 pi. These are now at every pi, it's undefined. At 0, at pi, at 2 pi, at 3 pi, it's undefined. Now, what happened here? At pi over, this is pi over 2, we are now going to have a maximum value. So everything now, the high values are going to be the low values. So what's happened here is all of these points are flipped because it's the reciprocal. So all of these points are now flipped right here. So we have now this point on the sine curve is now going to be this point and this point and so forth. So what you now have, this is not the answer. This is going to help you guide you to get the answer to the cosecant graph. Likewise, if you flipped it over, right here. If you were asked to graph secant plus 2, what you're going to do is you're going to really graph the cosine t plus 2. So replace, so one cosine is now going to be replaced as, if you do this, you're actually doing the secant curve. The cosine and the secant are reciprocals of each other. So you're going to graph this, take this secant out and write cosine. You're going to graph the cosine curve. What does the cosine curve look like? Plus 2. You're going to go up 2. This has an amplitude of 1, so you start high. You go up 1, down 1, down 1. So it's above, on, below, on, above. That was one full period. We did these last week. So you're going to do them with a broken line. Graph the cosine curve plus 2 with a broken line. And anywhere you have a 0 is going to be an asymptote. Because, see this point? This was over 1 up 0. So now it's going to be, when you do 0 over 1, it's now going to be 1 over 0, which is undefined. That's why these are asymptotes. These are asymptotes. Now, this low value will be the high value. This high value will be the low value. So actually, your graph are these little parabolas. Now here's some information for you. The cosecant curve is 1 over sine. Now, what did you notice about the domain? The domain was all real numbers for the cosecant except multiples of pi. Let's look at it on this page here. So we had, here's 0, this is 0, at pi, at 2 pi, at 3 pi, every pi you had an asymptote. So it's undefined here. Okay, so your domain for the cosecant is it's all real numbers except multiples of pi. Now your range, and you guys, I wrote this wrong, it should be negative infinity to negative 1. Fix it for me, please. Union 1 to infinity. That's the range. Let's talk about it. The range went from, on these, it went from negative infinity to negative 1, and then positive 1 to positive infinity. So these are the y values. This middle part is not the answer. It's just a guide to help you graph it. Okay? Now, if you looked at the sine, the cosecant, I'm sorry, the secant, here's your secant. For this one, where your asymptotes are at odd multiples of pi over 2, that's pi over 2, that's 3 pi over 2, and so forth, 5 pi over 2. So at odd multiples of pi over 2, you're going to have an asymptote. And again, this is messed up. Your range should be this should be first. You do your lowest to -1 and then union, and there's always a parenthesis at negative and positive infinity. And we talked about the sine curve as being an odd function. Why is it an odd function? This is the sine curve. So the cosecant is also odd. And we talked about the cosine as being an even. Here was the here was the cosine. This was even because it had symmetry on the y-axis. So secant is also an even function. So all this information here is the history of why the cosecant and secant looks the way it looks. This is the background. You have to understand what the relationship between sine and cosecant is. All it is 1 over sine. So where you get these numbers from is you're taking your instead of it being y over r, it's r over y. That's where all these numbers come from. So these are the fractions of the sine curve, and these are of cosecant because you were flipping your numerator and your denominator, and this is what results. Not in pink. In pink is the sine curve. The cosecant curve is this stuff. It's this answer, all of these. So today, what we're going to do is practice graphing these secant and cosecants. So I want you to get your back page. This is your homework. These are all the graphs that you're going to have to do today. Now, what you're going to do, you're going to graph, for number 1, you're going to graph the cosine curve. That's what you're going to do. So, with a broken line, how do you graph the cosine curve -2? And again, the directions are from -2 pi to 2 pi. So what you're going to do is start at -2, which is where? Right here. Here's your new x-axis. New x-axis at -2. The amplitude of this is a 1. What does the cosine curve look like? What would this look like? Well, you would start high, and you'd go above, on, below, on, above. Okay? So I'm going to do a broken line. I want to have a contrast between this graph. This is not the answer, but what it's going to do is help me graph what I really want, which is the secant -2. So now, if you were to flip all of these points, what would you have? Well, the first thing that I do is I take my zeros, and I know that they're now asymptotes. So I make a broken line in between here, here, here. So at pi over 2, 3 pi over 2, you should have an asymptote. And now, my answer, see these highs and lows? These are gonna make little parabolas.
Whoa, whoa, whoa. You just make parabolas at the height.
Mm-hmm, yep, it's like the vertex. Yep. In the you have to understand why it's all of these points, it's flipped. It's 1 over, so you're flipping all of these points to get this picture. These points are being flipped over here. So these points are being flipped. That's what happens. Let's do another one. Number 2. You'll get the hang of it. What am I gonna graph? Not 2 cosecant plus 1. I'm gonna graph 2 sine plus 1. So we did this last week. How does this look? Start where? 1 unit above the x-axis. That's our new x-axis. What's our amplitude? 2. How does the sine curve look? It starts on, it's gonna go 2 above. Okay, is that our answer? No. That's gonna give you your asymptotes. Where are your asymptotes? At all the zeros. There's 1. Another one. So now your answers are gonna be here. Here, here, and here. Questions? Okay, number 3. Can you fix the order of this? -2, and you're gonna grab the cosine. And I don't care if you use x. Most of the time you use f of t. I love x and y. I'm just used to x and y, so I will rewrite it like that. Now, how does that 2 cosine x plus 4 look like? What should you do? You're gonna start where? 4 up. Right here. Now, it's an upside down. So instead of starting too high, what do? Too low. Okay, is that our answer? No, it's not. We've got to put in our asymptotes. And your graph is going to look like this. Now, actually, I did a boo-boo. Right here, I should have stopped. And I shouldn't have put this asymptote in. Why? Because in the directions, it says graph from -2 pi to 2 pi. So they only want from here to here. So don't give more than what they're asking for. If it says negative 2 pi, do not extend past negative 2 pi. Number 4. What are you gonna do here? Start where? You're graphing negative sine x plus 3. So where do you start? 3 above. So now, instead of going on, above, on, below, on, what are you gonna do? Instead of on, above, what are you gonna do? On, below. Yep. On, below, on, above, on. Oops. Some people will use like different colored pens, which is fine. So where are your asymptotes? All of the zeros are your asymptotes. And your graphs are gonna be here, here. You wanna stay within these asymptotes. And that's it. Are you guys good with this one? Okay, now they get interesting. What did this look like? See if you remember. Now, I want, let's talk about for a second, what's the difference between, let's talk about the difference between this versus, do you remember what the differences between those two were? I'm just gonna do one little part. What's the difference between these? What do they look like? They look like bouncy balls.
Oh, yeah.
What's this one?
It's a bird.
Yeah, bird. So this one looks like that. Now, if you saw a negative under here, these would be upside down. So this would be, if it was a negative, it looked like this. And this one would be like that. So how are you gonna remember the difference between them? How do you remember them? Because, I mean, you could sit there and do a T-chart for all these, it'll take you forever. We did all that. We did the T-chart and why the numbers are the way they are. You're taking the absolute value. So now this one, I want you to be able to do it from memory. What are you gonna graph here? You're gonna graph 2 sine of x. What does 2 sine of x look like? Is it gonna split it in the middle, or is it gonna split on the y-axis?
On the Y.
In the middle, it's gonna be like this.
You literally just did that.
It's this one. Now that's what it looks like. So, where are your zeros gonna be? Here? 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 here, and there. So now what does your actual answer look like? That? Yeah. You get this?
Yes.
Okay, let's do another one. Tell me what to do.
Okay.
Graph what? What would that look like? It's gonna be upside down, amplitude of 2. It's like this. Upside down. That's the cosine, the absolute value 2 cosine. Is that the answer? No. What's the answer? It's gonna be all of these asymptotes in between. So it's gonna be this. Yeah. And now, do you notice how it says negative 2 pi to 2 pi? I didn't purposely stop halfway. It's because I followed directions. It said only graph from here to here. So I don't finish this one. I do half of it. Does anybody have any questions? Next one. Number 7. What should I graph? So start me off. Where do I start? Do I start on the x-axis here?
No.
I gotta go 2 up, right? 2.
Oh, no.
I know what you're saying, your steepness is 1.
Yeah.
Yeah, this is the cosine one. It's gonna be the bouncy ball. It's gonna split the y-axis in half like this. Would you call that one splitting, or would you call the other one splitting?
I would say this would be. Yes.
I think this one's splitting.
This one's
Yeah.
splitting?
Makes sense.
Okay. We'll say that this one's the one that splits. And then the sine one, how would you describe this? So we're gonna say this one splits. I look at this as a mountain. It splits the mountain. What's this one? This is in between the mountains.
A valley.
Like a valley, yep, good, valley.
I like that.
Valley, that's a good one. So we got it, splits and valley. Good. We need things to remember these things. Okay, so, what am I gonna graph now? I'm gonna put my zeros in. Next. Thumbs up, easy. Everybody? Okay, number 8, you try it and I'm gonna do it. It's a valley. They do take forever.
It's like the same thing.
Kate, you get this one? Thumbs up on this one? Yes? How about number 9? You're gonna start to get faster and faster at them. So this one, you're gonna graph what?
Yes.
The sine curve. What does the sine curve do? Is it on or above? It's on. What's the amplitude? 3. So you're gonna go 3 up. On. Below. and on. Do your asymptotes. Check your graph out, make sure it looks like that. Am I going too fast?
Kelsey, what's your question?
Yeah, that's not right.
It's not right?
No, I think you did
You did.
cosine.
No, you didn't
No,
finish it.
she's already.
I don't know what you did.
Here's,
You can finish the last.
here's
You
2.
didn't take it all the way like that, yeah, right there.
Oh, I didn't fit it. Oh, see. Oh, yeah.
Okay.
There. Sorry, guys. You're right.
It's all right.
I just didn't finish this piece. You guys are picky. I'm just kidding. No, that's good that you noticed that. That's very good, because that's one of the things I do look for when you're graphing them. Do you get this?
Yep.
Okay, what do you do here for 10? You're gonna go up 1. Up 1.
Yeah.
And you're gonna graph the sine curve, but upside down, right? Oh, amplitude is 3. Amplitude is 3. So you have your asymptotes. You get this?
Yes. Look at you.
Okay. Next one, you tell me what to do. Start where? Up 2. Then what? It's -2 cosine. So that one starts 2 down. What I do is I'll do it real light. You just want a contrast between the two. These are your zeros, and then you've got your highs Some people will use like a pen or a marker to graph them. You want to make sure that whoever's looking at this understands that there's a difference between, the whole thing is not this is not the answer. This is just like a, what would you call this? A guide to graph the actual -2 secant. Now for this one, what I would do, I would change my scale. I'm gonna make this 1 and this -1. So when I go to graph my sine curve that shifted down 1 unit, these are each like a half. So I would start here at -1. And it's 1/2, so now each of these is a half, so you're gonna go on, above, because otherwise it's too squished. So as long as you label your axes, I mean technically it should be in between here, but we're just doing this so we can see it. Put your zeros in. Everyone catch that one? So I started at -1, so each of these I did half. So this is 1, this is an amplitude. See, even though this is 1, looks like 1, it's really half. Number 13. Start where? 2, graph what? The what curve, sine or cosine? It's on, above, oops, 3 is the amplitude. Are your asymptotes? That's it, right? Number 14, where do you start? 1 below. And am I graphing the sine or cosine? Sine's upside down, right? So it starts on, and then you're gonna go 2 below. Do your zeros. Good?
Going really fast.
I'm going really fast?
Yes.
Okay, slow down.
I'm going just a minute.
Tell me when you're at 14. You're good? And unfortunately, ladies and gentlemen, we are almost out of time. So, I think we're gonna have time to do one more. Alexis, are you good?
But
Why don't I just have you guys finish the rest of your homework?
sounds
Good
good.
idea.
15. I want some nice graphs here. I want you to finish these. Okay? Do you guys understand this stuff? Is it okay? Yeah?